Okay.
Just
We
handing you over. Okay.
start off. I think Meena is there. Everyone is there. Okay. So good. So good evening, everyone, and good morning, right, to the majority of the participants here. I hope you are able to reflect on the assignment, right? Did anyone try the assignment? Any of you want to share the examples of supervised and unsupervised machine learning?
I did. I made a couple of examples.
Oh, please, then can you go ahead and share? Do you want to share?
Yeah, should I share my screen?
Yes.
Okay, give me a minute.
I've given you access. Please go ahead and share.
It says I cannot start sharing while the other participant is sharing.
I'll stop.
Yeah,
Okay.
I think you stop sharing. Yeah. Go ahead, Anirudh. Oh, that's good. Go ahead.
This is basically what supervised and unsupervised
Can
learning
you put
is.
yourself in the presentation mode? Can you click that? Yep. Good, man. Go ahead.
So this is what supervised and unsupervised learning is. It's basically you're doing an activity using a provided reference material or data set.
Mm-hmm.
And unsupervised means doing it without any reference or data. So this is basically the same example which we had last week. Machine is told what an apple is.
Right. This is what, this is a good summary. Yes. Okay. Go ahead. Yeah.
So these are 3 or 4 examples which I found in the daily life. So first, supervised as a child learns to run by watching other people do the same thing.
Okay.
Unsupervised means a toddler learns how to stand on his 2 legs by experimenting. Like he does not know how to do it, so he just keeps trying to do it over and over again until he gets it.
Okay.
So
Okay.
second one, a regular user, so suppose for you and me, we have YouTube accounts. So our recommended feed is kind of tuned into what we want to watch or our preferences. But for a newly created user account, it has a fairly generic recommended feed because the machine has nothing to reference to our preferences.
Okay. I think, yep.
The last one is when you upload a picture to Google Photos and you specify the location for each one of them. So the software groups the photos according to the common location. So based on the location, it groups the photos. But when you don't specify any location, it groups them on the basis of who is in the photo without actually identifying the person. So it shows the same photo for multiple people.
Mm-hmm. Okay.
So that's about it.
Sure. I think good attempt, Anirudh. Good first attempt. Although it needs a bit of refinement, right? I'm sure you will make it as we go along. Okay. I will go through everyone and then give my observations in terms of where you need to tweak. Anyone else want to share?
Yeah, I made a presentation.
Go ahead, Kesha.
Mine is actually very AI friendly by that I mean it uses AI a lot and compared to Anirudh's, which used a lot of situations.
Yeah. Are you sharing? Yep.
So yeah, this is supervised. I used basically 2 examples. So I said an AI learns by accepting.
Sorry, Keshav, can you minimize or remove this Chrome OS? You are sharing your screen that is coming. Yeah, you can close it. Thank you.
So an AI learns by accepting data that has already been tagged with a name or label. So I said that I'm basically using the same example that was presented in the last class, except I'm using a pencil instead.
Right.
So an AI, so there are 2 things being used. There's the data and there's the annotation, or you can also call it the tag or the label. So the AI puts those together and says that data being put in, or in this case, that picture is a pencil, but specifically that picture, obviously. So the next time the AI will encounter this picture, it will tag it as that is a pencil. So then there's unsupervised learning, where it uses deductive reasoning. So an AI learns by deriving a pattern by fragmenting given data in order to come to a conclusion. So the AI recognizes that for each number, for each number in the arithmetic sequence, the rule is add 2 for every term. So therefore, the next number is going to be 12. So those are the two examples that I gave, very AI based.
Right. See, your first one is bang on, right? If you take the second one, if you really see unsupervised learning, it actually groups similar things and dissimilar things, right? So the output will be all the it will try to group 2, 4, 6, 8, 10, right? In such a manner, it will try to find some kind of commonality, right? And then say that, for example, all the single digit ones will be grouped together. All the double digits will be grouped together. Then all the tens will be grouped together, right? That is 10, 20, 30, like that. Because an unsupervised learning is actually a grouping algorithm. Please understand. And let's say if it finds an odd number, it will classify it as an outlier. You understand?
So will it just make the deduction that all of them are even numbers?
Of course, all are even, but it will try to group, right? Even
Yeah,
within, right? Exactly. So that's what it will do. Like I said, all the single digit will be grouped together. All the double digit will be grouped together. Then all the three digits, right? And probably it will group all the tens, right? Something like that. All the tens it will group together. All the, 10, 20, ones that end in zero. That will be determined by the algorithm.
So whether a number is single digit or double digit.
It can any kind of grouping. What it feels as a meaningful grouping is what it will do.
Okay, I
Right?
understand.
Right. So Anirudh, the same applies for you also, right? I think when you are talking about YouTube and recommending, please understand that unsupervised is basically a grouping algorithm, right? Because there are no references or labels. It looks at the characteristics and tries to group them into similar things, dissimilar things, and outliers. Okay. Good. Let's. Anyone else want to present? Thank you, Keshav. That's a good attempt. It's come out well.
Can I present?
Yes, please. Yes.
Okay. So for supervised, when my mom first made fish, when I first smelled it, I didn't know what it was. My mom told me that it's the smell of fish. So whenever my mom makes fish, when I smell that a certain scent, I make a prediction that my mom made fish. And similarly for a police, when some sort of witness says that the suspect for a crime was had a lighter skin tone and was about 6 feet tall, the if a description matches one of the suspects, then the cop can predict that that certain suspect is the criminal. And whenever a scientist sees that there are two hydrogen molecules and one oxygen molecule, they can predict that it's H2O. So for unsupervised, I have a lot of pairs of shoes. So if two shoes look similar, then I group them together and put them in a separate area on my shelf. And for shirts, I have shirts for winter, which are like long sleeves. So I group those in a separate pile. And then I have a few shirts that are like short sleeves that I wear during spring and summer. So I group those in a separate pile. And then I have a few formal shirts that I also group in a separate pile. And a teacher, when she has to give back assignments at the end of the year, she will look at the name and then group those the test papers together and then hand it to that specific student.
Okay, good,
Uh,
good.
yeah, that's all.
Yeah, I clearly understood the shoe on the shirt. Can you tell me the teacher one once again?
So looking at the name at the top of the paper, the teacher will group the same name together and then hand it to the student.
Okay, okay. Yeah, yeah, kind of. Yes, yes. You're right. You're right. See, I think in the previous one, the ones you shared are also very interesting ones, right? They are very relevant. If you see, I think you are all grown-ups, right? You understand the racial profiling that happens, right? So that's one of the pitfalls, right? Because at the end of it, AI is operated by human beings. It's up to us to ensure that it is not used for, any kind of, racial profiling and the like, right? But as having said that, it is being used at some places, right? So the similar and dissimilar. Okay, so that happens. So very good. In fact, I want all of you, to bring real life examples like what Shashank is bringing, right? I think these are very clear examples. Let's try to build on it. Thank you, Shashank.
Should I share now?
Yes, yes, go ahead on.
So, the first one I used was like Tesla. It uses like the camera and sensors, and it sends data to the module. And what it does is it analyzes that data, and then it'll start like making it's able to learn what it's driving around, like if you're going on your way to work and then there's like this really broken really eroded stop sign. You'll take a look at that stop sign, and then based off all the other stop signs it's seen, it'll recognize that's a stop sign. Then I also have like our iPhones. A lot of our iPhones, if we still have the button print recognition, what we do is we have to place our finger repeatedly so it recognizes that pattern, so it can tell whether it's your fingerprint or not. And then like voice recognition, I had, and then I also had the X-rays, like in radiology, humans look at X-rays, and then based on how they look, they can see what kind of problem the human body has. I mean, AI also has been in that field too. My next one for unsupervised learning is like handwriting recognition. Like it groups your handwriting based got cut off there, based on how your handwriting looks. Like it'll group certain words, like how you want it to look like if you have someone else writing or something like that. Then I also have like K clustering. So it's an algorithm that allows people to group things. And then so I had like two examples I wrote down. Like a teacher splits a class based off their shoes, like what kind of shoes they had. Like if like 10%, like 30% of the class had Nike, and like 50% of the class had Puma, and the other had Adidas. Or like a manager can organize their customers based on their spending behavior. So I had those as my examples.
Very good examples. Very solid examples, right? Just that I want to add that handwriting, right? It's a kind of supervised. Okay. In fact, all the images that you see, we are going to spend a lot of time on dealing with numbers. Okay. Whenever there are images and and similar things, it belongs to a more advanced form of AI called as deep learning. I mentioned that, right? So in a way, handwriting is supervised because it from labeled data sets only, that it understands, right?
Okay.
But otherwise, very good examples on, right, whatever you shared, especially manager organizing customers. I think those are the kind of examples I want you to think, right? Because many of you are going to graduate to college, or in the process of moving to college, right? So you need to think from application perspective. Always think from application perspective. It will not only you will understand things better, it will help to clarify many of the doubts, right? So good examples on.
Okay. Thank you.
Thank you. Who would like to go next?
I can
Meena?
go next.
Yes, Meena, please go ahead.
Okay. Share my screen. Okay, so for example one, I used waste sorting. So for supervised learning, if a person could be taught the difference between each subgroup of trash. So they were given separate baskets, each containing different types of waste for like recycling, trash, glass, or compost. And then from then on, they would be able to categorize the waste they received into one of the 4 baskets because they had previously learned what each type looked like.
Yeah.
And then for unsupervised learning, I said that a person could be given a basket with all the different types of waste just combined into just one basket. And then from there, they would be able to tell the differences between each piece of waste and then separate them into different categories based on that. And then for example 2, I used e-commerce. So for e-commerce, I said with supervised learning, data from each purchase could be inputted into the website or app's algorithm. And then from there, if a person bought tea, for example, like Earl Grey tea, then from then on, the algorithm could recommend like different types of tea to the customer. And so I was trying to, I didn't really understand unsupervised learning, like association with through unsupervised learning. So I try to come up with an example for it, but I'm not sure if it's right.
Yeah, I think your unsupervised learning is correct, right, in both the scenarios.
Okay.
The unsupervised learning, see, you saw, right, what others presented. In unsupervised, there is no labeling, there is no reference. All that the algorithm doing is kind of grouping it. For example, if there is no reference or anything, right? See, some data will be there. It's not like no reference is there. What I am saying between supervised and unsupervised is reference to the kind of output we want.
Yeah.
Right?
Yes.
That won't be there in unsupervised, right? So in that case, what it'll do, probably it can group even all the South Asians together, right? All the whites together, all the blacks together, right? All the Hispanics together, and accordingly suggest. That's unsupervised.
Okay.
Right?
Yeah.
Right? Or alternately, it can group based on the ages also, right? It can group all the millennials like you together.
Yeah.
Right? Because, and then baby boomers, and all that are different.
Yeah.
Right. So it unsupervised, a reference or label to the kind of output we want is not there. Right? Please understand that.
Yeah. Okay.
Right.
So,
but otherwise, very good examples as far as the supervised is concerned.
Okay. So would this make sense for saying that with unsupervised learning, if someone bought tea, then from there they could
no, that is supervised, right? That is still supervised.
Okay.
Right? As I said, in unsupervised, it's only grouping similar things and dissimilar things, as outlier. That's all the unsupervised learning is doing.
Okay.
Okay. Sure. Anything else, Meena?
No.
Okay. Anything from your economics, right? So what I suggest is, in addition to looking at everyday examples, look at examples that, that relate to your line of work, right? Line of study, or your preferred line of study, right? For example, if you take the example of economics, right? I have all the countries. If I group the countries as high income, middle income, and low income, I'm talking of supervised learning, unsupervised learning, right?
So then what's the difference between clustering and association? Because
we will see that. We will see that as we go along.
Okay.
Right? We will see that as we go along.
Okay, thank you.
Okay, sure. Who would like to go next? Any of you want to present? Okay. Yeah, Nitish. You want to share?
Actually, I missed the last class. My examples aren't that good. Like, honestly,
No,
I kind of
it doesn't matter, man. Come on. You can talk through as well if you want. I know you missed it. Yeah.
I'll just share my screen. Wait a second.
Sure.
Wait a second. Let me just put this in present mode. Okay, so I just gave some examples about like just supervised learning. So like just brushing your teeth every day would be considered supervised learning, I guess. And I guess just you eat food every day, so that's another example. And if so, say
That
you
won't
have
be a super. See, we always want to have an output, right? At the end of it,
okay.
right? So that won't come under, you've stated, you've given the example of patterns, right? See, for example, your last example, running a set amount of miles. If I am going to predict how many miles you will run next week based on your past patterns, then I am talking of supervised learning, right? You understand?
Yeah.
Right? On the other hand, if let's say all of you are running, okay, all the 7 of you here are running, okay, or let's say runners. I want to categorize you as, marathon runners, short sprint runners, right, or decathlon runners. If I'm categorizing you, as 3 groups, then I am talking of unsupervised learning. You understand?
Yeah.
Right? Because in supervised, there is a clear reference to the kind of output we want. That kind of reference to output is not there in unsupervised learning. So please understand the difference. Right? If you see the example, yes, sorry, go ahead.
So say you say you eat like rice every single day, would that be considered like supervised learning?
No, that's
Because
a pattern. See, that's a pattern, right? See, that's an activity. What is it that you want as an output? See, always think from input, process, output, IPO, right? That's how a program works, right? Here we are talking of a computer software. We are trying to solve a problem, right? So always think from an input, process, output perspective, because that's how the computer thinks. So you should start thinking like a computer, because only then you can write the best of the programs, right? So I'm inputting something, program is going to process something, and it's going to have an output, right? So what is the input, process, output, in eating food? It's an activity, that's all, right? You understand, Nitish?
yeah,
See, output is what is it that you want, right? What is it that the organization or the company wants, right? Or if you're running a company, what is it that your customers want? Always think from those perspectives, right? So it's all output, from an output perspective we are seeing, right? Okay, so let's move on. Any other examples you want to cover, Nitish?
no, not necessarily.
So you understand, right? What is machine learning? What is the difference between supervised and unsupervised? Do you understand that?
Yeah.
Right? Right. So can anyone, can you tell me what is machine learning, Nitish? And even fundamentally, what is a pattern?
Yeah. Fundamentally, a pattern is a consistent, recurring characteristic.
Good. That is recognizable.
Yeah.
Right? Some are easy to recognize, some are difficult to recognize.
Okay.
Right? A pattern is a consistent, recurring characteristic.
Yeah.
Right? What is machine learning? Okay, machine learning is about identifying patterns, right? So here we are making the software identify the patterns for us.
Okay.
So how will the software identify the patterns?
By input and output.
Sorry, could you come closer to the mic, Nitish?
By input and output.
By input and output, what actually software does is it studies the characteristics of the patterns. That's what we do, right?
Yeah.
If you have a checked shirt, your mind is actually looking at the check box, right, in the shirt.
Yeah. Yeah.
So you are studying the characteristic, right? So the same way the computers assess, evaluate the characteristics of patterns. Okay. How are the characteristics of the patterns represented? See, we can see with our visual eyes, right? We can understand that this is a square because we have learned a lot of things. So how will the computer understand the characteristics of the pattern? Remember, we saw that example of what is that? The apple, right?
Yeah.
So how will the computer understand the characteristics of the patterns?
By giving it like an identity.
Actually speaking, we said, this is like a shape, this is a protrusion and all that, right? So
Yeah.
the characteristics of the patterns are represented in the form of numbers. If it is represented in the form of numbers, computers can understand, right? The
Yeah.
software can understand.
Yeah. Yeah.
So machine learning is about studying patterns, understanding patterns. Here the software is identifying the patterns
Yeah.
by evaluating, studying the characteristics of the patterns. And the characteristics of the patterns are represented in the form of numbers. Right? Yes or no? The characteristics of the patterns are represented in the form of numbers.
Yeah. Yeah.
Right?
Yeah.
Then it is easier for the computer, right? Otherwise, it is
Yeah.
difficult for the computer.
Yeah.
Right? So now all of you understand what is machine learning? Machine learning is about identifying patterns. Right?
Yeah.
Instead of humans identifying patterns, the software is identifying the patterns. And the software identifies the patterns by studying the characteristics of the patterns. For example, this is a shape, it's a kind of a circle, right? Protrusion, red color. Color can be represented in the form of pixels, right? The shape can be represented in the form of height, width, depth, right? This protrusion can be represented in the form of an angle, and color can be represented in the form of pixels. So
Yeah.
all the characteristics of patterns are represented in the form of numbers, right? So which is why machine learning is actually at the intersection of computer science and math and statistics. Okay. If you see the typical software, right, the software development that happens, right, it can be developed, let's say an e-commerce software or whatever, right? It is actually at the intersection of domain knowledge and computer science. Domain knowledge is what? I know what to do. I know what is expected of the software, right?
Yeah. Yeah.
Right. So machine learning, of course, domain knowledge is important, right? No doubts about it, is a given. But more importantly, machine learning is at the intersection of computer science and math and statistics. Please understand this. Which is why, as one of the modules, we are going to cover some applications of mathematics. You understand? Right? So now you see all the pieces of the puzzle are fitting. Right? So having understood what is machine learning, what is supervised, what is unsupervised, having also understood that machine learning is actually at the intersection of computer science and mathematics, let's see what are the recent developments, in the world of technology that is fueling the AI wave, right? Remember, I showed the AI Where is that? Let's quickly see the history, right? If you see the history, it's been around from the 50s. But it's only recently that there is a lot of developments. Remember, I mentioned that, right? So let's understand for a moment, okay? What are those things? What are those advancements that are taking place, right? So one of the developments that has happened is in the area of databases. Can you tell me what is a database?
Database is a collection of information.
Sorry. Can you be a bit louder?
A database is a collection of information stored in tables.
An organized way of storing data.
Good. It's an organized way of storing data, right? It's of course collection of data. It's an organized way of storing data. See, before computerization, people are still maintaining records. It's also called a database, right? It's just that, if let's say you are a student, okay, the school, 70 years back and all, people, if you go to your schools or old schools, you will see the school would have maintained records of, individual students, how much marks you have obtained, all of that would be handwritten. That is also a kind of database, right? Yes or no? It's an organized way. I'm storing information. Now I have got computers and I'm storing, right? So a typical thing, basic concept, in a database is we have tables. Tables is nothing but a collection of rows and columns, right? If I'm a student, my name and marks are stored. I have, what is called as, this is the first row where the details are there. And here, you will have field values, right? So column is the collection of field values of the same type. A row is a record. Okay. So this is what is called as, a database, right? What has happened is, if you really see in the recent times, right, when you're talking of a student record, we are talking of numbers, right? What is called as structured data. What will you call, say, a YouTube video? What will you call a YouTube video as?
On unstructured data.
Yeah.
Right? It's called an unstructured data, right? I also have video, I have audio files, I have text files, right? PDF documents, images. And if you see, especially with the arrival of Instagram, right? And the mobile phone, the number of images, videos has been skyrocketing. So
Yeah.
right? So the current way of organizing data, right, is not helping us. So it's known as the big data. So big data is actually the unstructured data predominantly, and some structured data as well. So this is also fueling the AI wave, right? A lot of unstructured data is available for us to analyze. Because one of the requirements, for machine learning is you need lots and lots of data so that your software can identify the patterns. You're going to see that when your when your historical data contains fewer records, right? The accuracy is invariably low, right? So I need large amounts of data, and that's been made possible by the arrival of mobile phones, right? We are
Yep.
clicking more photos, right? Yep. And what has also helped is, it is not just all those, data, but the hardware and internet revolution, right? The processing power of computer has increased like anything. It's an exponential increase, right? And the cost of internet has come down, right? Your storage cost has come down, and there is an exponential growth in data, right? And all of this has happened in the last 4-5 years. Yes or no? So
Yeah.
all these things together are fueling the AI wave. If these had not happened, you and I won't be, sitting here and talking about it, right? So AI would be relegated to the research and development institutions. So AI has become mainstream because of all this, right? Our own behavior, right? And another thing that has happened is what is called as GPU, right? GPU is nothing but, how many of you have heard of a gaming laptop?
I have. I have.
Okay. You have a gaming laptop. You know that it is faster, right?
Right.
Right?
Yeah.
Compared to traditional laptops, your gaming laptops are faster. And typically they will have NVIDIA, right? What you have in the traditional computers, right, your laptops and the PCs is what is known as CPU. What you have in gaming laptops and other high-end processing systems are what are known as GPU. GPU promotes parallel processing of data, right? Today I can buy a GPU unit fairly easily, in the sense, it's not costly, right? It's not out of bounds.
Why don't we use GPUs in regular computers?
Sorry?
Why don't we use GPUs in
You
regular
can
computers?
use, in fact, your gaming laptops will have GPUs, right? What I want you to go and check, okay? One of the things I want you to check is how many cores are there? Do you know how many cores are there? That's the partition, right? Within your memory. If it is a CPU, the number of cores decide, how faster your laptop is, right? If you're using a CPU, even if you have more cores, it's still not faster, because the way GPU processes information is much different. GPU processes information, in a parallel manner, right?
Yeah.
Why this is needed? Because my algorithm or the AI model needs to guzzle, huge amounts of data. So the traditional way of processing data is not helpful at all. In fact, between CPU and GPU, there is a 600% improvement in processing time. Okay, so don't go and go looking to buy a GPU. I'm not saying that. Okay, your for the kind of work that we are going to do, CPU is good enough, right? Even for commercial establishments, CPU is good enough. Where GPU is needed is when you are dealing with images. Remember the unstructured data that I talked about, images, audio files. If you're going to process that, GPU is helpful, right? I think most of you have got an 8 GB or a 16 GB laptop. That's more than sufficient to do many applications. As I said, we run a company, all the commercial applications, are developed using that kind of laptop, right? That is more than sufficient.
Sir, I have a question.
Yeah.
Yeah, whenever you're buying a laptop, in the specifications, it says something called RAM. What is RAM?
RAM is the internal memory.
Oh, okay.
Right? You will have
Yeah.
RAM. Yeah, it's the internal memory. So when I said 8 GB, 16 GB laptop, I'm referring to the internal memory.
Okay.
Okay. So
Yeah,
in addition to that, you have cores. In addition to that, you have something called frequency. If you go and see all the system information, you can see all of that, right? All of that determine your and your hard drive. So all of that determine your processing speed, right? But GPU, it's like it takes you to the next level.
Sir, I also have a question.
Yeah.
Usually machines come with a combination of both CPU and GPU, right?
No. GPU is separate, as I said.
You said gaming laptops have a GPU.
See, that's why I said gaming laptop, will have a GPU, right? It's an additional unit. Mm-hmm. See, there is a core processing unit. In addition to that, you are talking about the GPU. Okay. In the laptops that most of the people use, okay, we are talking of a CPU. We are not talking of a GPU.
Why don't we use GPUs instead of CPUs?
It's a question of cost. It's a question of cost. We can very well use GPUs, right? But as I said, the cost is also coming down. But the kind of computers we need, if you have to process complex models, right, like the ones used for driverless cars, right? So you're talking of huge processing power, right? So understand that, the hardware revolution has also contributed, right? We are capturing far too much information, right? About ourselves, about our process, about our activity. That kind of thing was not there, in the past. Just to give you an example, in the case of healthcare, how many of you know Fitbit?
I do.
I
You
do.
do, right? So Fitbit captures what? In addition to the number of steps you take, it captures your
Heart
Heart
rate.
rate,
pulse rate, right?
yeah.
Right? Before Fitbit and those kind of products came, people were not measuring their pulse rate on a continuous basis. They will measure pulse rate when they go to a doctor, right? Or when they have some serious complications, doctor will prescribe, and probably the doctor will teach the patient how to measure pulse rate. You measure pulse rate and see for yourself. Now Fitbit has come. Everybody knows the pulse rate at different times of the day and on different occasions. Yes or no? So I have so much information about myself. In fact, doctors did not know before the arrival of Fitbit and similar products what is the typical, pulse rate at different times of the day. This is a fact. See, they can make an intelligent guess, right? But not for a whole population, right? So that's the kind of data. So somewhere the data needs to be stored, right? Somewhere the data needs to be processed. So that's why we are talking of GPU and the like. Okay. So along with
Yeah.
that, yes. So I mentioned, I think there are two people, right, who are from the IoT group, right? Who are the two people? Just for my, it's
Uh,
Anirudh and
No, my brother was in the IoT. I wasn't.
okay, fine.
And me.
Okay,
yeah,
sure.
I was
So,
there.
right. So you were there in the, so I also asked the question, how is IoT related to AI? Did you think about it? So we will see that, okay? What is an IoT? IoT is two systems that are connected. It's an interconnected system. That's all,
Yeah.
right? Do you know that your mobile is an IoT device,
Yes.
right? Your mobile is an IoT device. How is your mobile an IoT device?
It's connected to the, I can say signal, like Wi-Fi. So
Of course,
through
the
the,
signal is there,
so
but it's actually a medley, right? A combination of different devices. How many of you know that using a mobile, I can find the number of steps I take in a day? Do you know that?
I do.
Yeah, I did.
My mom's phone kind of shows her heart points and like the number of steps she takes. Yeah.
Right? Your mobile can tell that, right? It's known as what is called a pedometer. It can tell the direction. It can even tell the speed, right? It has a fingerprint. If you see, all of them are devices, right? It is just that it is sitting inside one big device called a mobile phone. How it works is through sensor technology. Okay. So we are not here to talk about IoT, but I'm trying to link different concepts so you understand how all of them are converging. Okay. If you see the bottom line, the key point that I wanted to convey is your IoT device, right? Today, there are more IoT devices on the planet than there are human beings, thanks to mobile phones, right? So there are more interconnected devices on the planet than the population. This is a fact. All those devices are capturing all information, right? They
Yeah.
are collecting, right? Pulse, your BP, ECG, on the healthcare side.
So Wi-Fi is IoT. Like it's
Wi-Fi is a means.
means of
It's
okay.
a means, right? Because it is through Wi-Fi that you or on Bluetooth, right? It transfers the information,
Okay, yeah.
right? Let's say, for example, I want to monitor my blood pressure. I have a device that measures the blood pressure, and there is a sensor that transmits the blood pressure, right? And that is connected to another device, right? Over the internet, it transmits whatever BP that is there. If you see, that's what is happening, right? You
Yeah.
understand? So I have so much information. Remember, I said the proliferation. The mobile is is an important inflection point actually. Mobile, the smartphone came. When did the smartphone actually come into being?
Around 2007, 2008.
Right? 2007, 2008 onwards. So from that moment onwards, there has been proliferation in terms of the data about ourselves, about companies, about their process. Remember the example of healthcare I gave. Before that, people did not know so much about their patients. Today, if you ask, what is the sugar value when you get up? What is the sugar value you have after breakfast, after lunch, after dinner, before going to sleep, at sleep? Imagine there is a device that measures. How useful it will be, right? Today, doctors don't know the information that I'm talking about. Most of the doctors don't know. They only know that, after eating, there will be a spike in sugar value, right? Especially if you eat carbohydrates and sugar,
Yeah.
sweet items, right? Beyond that, people don't know. They know that, in sleep, it can fall for people with low sugar, it can spike and all that. But they don't know for majority of people how sugar, increases, decreases. See, there are being attempts, the one I'm taking the example of sugar because some attempts are going on now. Just like how the Fitbit captures the pulse rate, an attempt is being made to capture the sugar value on a continuous basis. Imagine how rich that information is, right? People can take actions, doctors can understand the bodies better. So that's what is happening, right? So you have huge data that is being generated, right? It is giving opportunities to improve ourselves. And similarly, customer information, right? If I am an organization, so much of customer information is being generated that was not there 10 years back. So the need for all the big data, GPU and all that were never there, right? Because my world was a lot simpler. Today, the world is, generating so much of data, trillions of data. They are, calling it as petabytes, zettabytes, whatnot, right? Okay, so that's how the world is moving, right? So all of this information, an organization, an individual can make use of using AI to take intelligent decisions. Because the kind of data that is being collected was not there 10 years back. So today in IoT we use the word smart sensors. That was not there before, right?
Yeah.
People had mechanical sensors, electrical sensors, but it was not a smart sensor. So and especially mobile, right? It's a game changer. Today you can view, your CCTV feeds in your mobile, right? I can process, and I can build an AI system that can tell whether there is an intrusion or not. Yes or no?
Yeah.
Yeah.
Right? So that's how, all these technologies are converging, right? What we are talking interested in this program is about AI, right? The data is
Yeah.
there, right? We are not bothered about the collection of data, right? But as part of your project, you have to go through the process of, collecting data. But where the portion we are talking is data is already there. How I'm going to make use of the data to understand better and make intelligent decisions. That is the part that we are concerned in this program. And as I said, there are three components, right? One is the software programming component. The other is the mathematics component. The other is the application component, right? We are going to cover all three. So as people, as at crossroads in life, you can make use of the information from this program to decide where you want to specialize, where you want to be, right? You may choose that you love numbers, so I'm going to focus on mathematics. Yeah. Someone can say that, I'm interested in programming, so I'll go focus on programming. Someone say, no, I'm not interested in any of that. I'm more a business guy. Okay. I'll make use of AI to build a better world. So it's up to you, right? So this group that way is unique, right? You are at crossroads, many of you, right? So you're going to use this information to decide what you're going to do in your future. So, but we will expose you to all the three elements. Okay.
Yeah.
Right. Another key term that is often used, in the context of AI is Industry 4.0. How many of you have heard of Industry 4.0? If you see IoT, when I'm talking, I'm typically talking of consumer IoT, right? If you see all the examples that I gave is consumer IoT, right?
Yeah.
Can you give an example of an industrial IoT?
A steam engine?
Sorry?
A steam engine, because it has different parts, like it has the coal, it has all the other parts.
No, not steam engine, right? See, understand this. See, IoT is what? It is capturing some information through sensors, and it is sending that information over the internet to another system. And
Tesla,
using AI and other things, you are processing.
Tesla cars.
Can you elaborate?
So when Tesla gets data, it'll send that data to other cars around it to so the other cars can see what the roads look like.
Yeah, kind of. But can you give a better example? I have a car. What if I tell you that next week your car is going to have a breakdown? Yes? Are you getting it? That I am talking of an industrial IoT. I have huge machines in my factory, right?
Yep.
I want to know when those machines will fail. If you see some of the machines, a cooling tower in a factory. Do you know what's a cooling tower? It's an equivalent of a aircon that you have at home, air conditioner. Here we are talking of a massive, gigantic cooling tower for a factory. It'll be, the size will be like, at least 25 floors. That's how big it'll be. I'll try to bring and show you a photo in on the next class. Okay, how big a cooling tower is. So it's a big headache, to maintain them, right? Because if the machines fail, the production stops, and it's a loss to the organization, right? So I use, just like how a doctor can use information from patients, vitals, right? Information like heartbeat and all that, BP and all that. An engineer managing those machines can use the information from the machines. There also the concept is IoT, right? So instead of measuring pulse rate BP, there I will be measuring speed, vibration, pressure, temperature. That's what matters in a machine, right? So over an IoT system, all this is passed on to the, my application layer, right? It is captured and I analyze, I monitor, and then I decide, oh, this part is going to fail, is it? Next week, let me go ahead and proactively replace. That field is called as predictive maintenance. You might have heard of preventive maintenance, right?
Yeah.
Right? What is preventive maintenance? What is preventive maintenance?
So you can like prevent any kind of repairing that's required to your car. I don't know.
Keeping something in good condition to prevent it from going down or from breaking down.
Right. So what you typically do when you buy a car or a motorbike, the company will say that, after every 10,000 kilometers or 10,000 miles or 1 year, you leave your vehicle for preventive health check. Right? I have a schedule. That's known as preventive maintenance. So the same concept is there for machines also in factories. But the pitfall is those maintenance schedules happen once in 6 months or once a year. Right? I don't measure, I don't look at how good my machine is, until it stops. Sometimes you don't know what is going on in the machine. This is a reality, okay, in many organizations. So IoT, industrial IoT, is actually changing the phase of it. I am able to predict when my system will fail. It's a very wealth of information, right? If you are running the factory, if you're the factory manager, the worst nightmare is when it fails. Right?
Yeah.
So that comes under what is known as 4.0. Okay. The key concept is this is what is called as, all the AI, the industrial IoT, everything is called as, comes under a broader umbrella called as, industry 4.0. That is an industrial revolution that's happening. If you see, it all started, with industry 1.0 in the end of the 18th century, right? When all these steam power, weaving looms came into being. Then around the beginning of the 20th century, we had the mass production, right? How to produce a product, in large quantities. This was pioneered by the mass production system introduced by Ford, because it is Ford that introduced 8-hour schedule, right? 3 shifts, 8 hour per shift, 5-day work week, producing something, in mass quantity. All of that come under, the assembly line, everything come under the industry 2.0, and Ford is a big pioneer in that. Ford Motor Company, right? Because it's a revolution. Everybody followed it. It changed the way, the world does business. And then came industry 3.0, where we started doing automation of things. Okay, computers and all that, early 70s it started happening. Now, from the last 10 years or so, it's about interconnected devices. As I said, there are more interconnected devices on the planet than there are human beings. Right? We are talking of smart homes. Right? We are talking of smart homes. We are talking of smart factories. Right? So please understand, the IoT, industrial IoT, all of them are feeders for us. They are feeders of information for us. Once you have the data, you are going to build an AI system that can make use of the data. Do you understand the end-to-end system now?
Yeah.
Yeah.
Right? So that's how all the different parts fit in. So IoT is just one aspect, right? Our mobile itself is generating a lot of things. Right?
Yes, sir.
So you will use all the data from all these systems and consumers, patients, everyone, and I will develop an AI system. Today, do you know that, by looking at the eye, okay, just a picture of the eye, people are predicting the kind of illnesses one can get in future.
And this is actually true.
Right? That's actually true.
Okay.
Right? So how is this possible? Right? So I study the patterns in the eyes, right? Between people who developed different kinds of diseases and people who did not develop diseases. So how easy it is for me to get a photo of the eye? I can use my mobile and take a pic, right? Of course, that's not good, but still something is there for the doctor to see. Yes or no?
Yes.
It's not the best way to look at someone's eyes, but okay. In some of the low-income countries, mobile is a game changer, right?
Yep.
So that's how all of them, are fitting and falling into place. Okay. Any questions?
No,
Any
sir.
thoughts? Any observations?
So I have a question.
Yeah.
Now we have gaming PCs that have a combination of both CPU and GPU. So you said that GPU processes the information, I think 600% faster than CPUs. So then
One second. I was talking about an AI application at scale. We are not talking of an application, that is run, as part of an academic program. We are talking of at scale, it is a deployed program. It is faster. Yes. A CPU cannot process that kind of algorithms compared to GPUs. Yes, go ahead.
So then wouldn't GPUs have faster processing power? Wouldn't that have been cheaper to just put a GPU instead of adding a CPU to the PC?
See, understand this. See, the technology is, if you see the GPU, that's only about 20 years old. The GPU actually came into being because of the gaming industry. It was not developed for AI. Okay. So gaming industry has indirectly contributed to AI. Right? Because in the late 90s and 2000s, we were not generating so much data, right?
Yeah.
So it was developed for the gaming industry, not for AI. So AI realized, hey, there is a faster processor, let me make use of it. Right? So the original intention, which is why, you see that original intention of GPU was for gaming. Right? Because gamers want faster, right? They get very agitated, right? I don't know how many of you are gamers.
I am.
No wonder you're asking so many questions. Okay. Right?
Whenever the ping.
So gamers become, if it is slow, they become very agitated, right? Highly impatient people. So CPUs couldn't do justice.
But GPUs don't actually process the games on their own, right? They process only the graphical part of the game.
Exactly. It's the graphical part, yes.
Okay.
Which is why it's called as the graphical processing unit, right? Yeah.
Okay.
Okay, so I think that brings us to the wrap of this session. Okay, so from the next session on Saturday, we will get into the Python programming, and we'll also cover concepts like what we did today, right? I'll keep sharing some of the recent developments, things that are fueling the AI wave. Okay, so what I want you to do is, I think many of you came up with very good examples of supervised, unsupervised. Based on my feedback, go ahead and clean it up, right? Basically, I'm asking you to improvise them and start putting together a deck. When I say a deck, a PowerPoint presentation. So what are the key learnings? What are the assignments that you're doing? So that, at the end of it and at the end of the project, you will have a nice little presentation, right? That's something that, will act as a reference for you, if you want to look it later, or if you want to share it with someone, right? Can be for AdCom, it can be for any other purpose, it actually helps. right? So please go ahead, improvise on your examples of supervised, unsupervised, right? Try to bring more examples related to the field of study, also the field of study that you are planning, so you can relate to things better, and also bring examples from everyday life. Okay.
Yes, sir.
Any questions, any other observations? Okay. So Ravi, I think we are good to close the session. Any closing comments?
Yeah, perfect. Govind, I think we'll meet up next Saturday. I really like the presentations these guys are making.
Yeah.
And as you rightly said, I think if they refine it further, that'll be very nice.
Yeah.
Great.
Okay. Thanks, everyone.
Yeah, thank you so much for your time, sir.
Sure.
Bye.
Thank you. Bye-bye.
Thank you. Thank you. Bye.